Hello, this is a final presentation for Environmental and Occupational Health at the University of Arkansas for Medical Sciences. This slide is simply a disclaimer that this is a student presentation using a hypothetical scenario for educational purposes only. The presenter is a student at UAMS, not a representative of the agency named in the following slides. The information contained herein does not necessarily reflect the views of said agency. Okay, my name is Tariq Salem, and I am an environmental health specialist today, and I'm here to talk to you about nanomaterials and environmental health. This PowerPoint will be a review of the benefits and hazards of using nanoparticle technology in our environment. So air, water, and soil pollution all have a direct impact on our environment. The causes of environmental pollution include fossil fuel emissions from industrial plants and even exhaust gases from the vehicles that we drive every day. Chemical waste and poor agricultural policies often lead to soil erosion in banks around rivers, and this will cause groundwater to become contaminated with hard metals that are toxic not only to wildlife, but to the humans who drink it. Nanotechnology is an excellent solution for environmental remediation, detection of these contaminants, and pollution prevention. In this presentation today, I will be discussing what nanoparticles are and why they are important to us and our environment. Then I will go into some of the common sources of nanoparticles and how they are created synthetically. The application of nanoparticles will then go over the different industries that make use of nanotechnology and what some of the specific products are that use it. The rest of this presentation will then focus on how nanoparticles are used in environmental remediation, what some of the potential health risks are that are associated with nanoparticle exposure, both in the workplace and in our everyday lives, and some of the risk factors and safety concerns that come along with using nanotechnology. What are nanoparticles? So, nanoparticles are defined as any material with a dimension between 1 and 100 nanometers. So, because of this, and due to their small size, nanoparticles have a large surface area to volume ratio, and they possess unique physical and chemical properties. Nanoparticles can be either classified as natural or synthetic, and they can be further divided into two subgroups of organic or inorganic. This specific classification is based upon their chemical composition. An example of natural nanoparticles would be carbon nanotubes formed from combustion. Another example would be something that we have all heard of, that is soot. So soot is frequently composed of black carbon nanoparticles that are released into the atmosphere due to the incomplete combustion of fossil fuels. We see this every day whenever we look at cars and we see the black air coming out of the exhaust pipe, or if you have a fireplace at home and you see the black soot that's developing along the brick of your fireplace. So I really like this this diagram at the bottom because I really think that it describes nanoparticles in a very simplified and clear way. So the four different areas that it looks at are the size, which we talked about earlier, which is 1 nanometer to 100 nanometers. Then it talks about the material. So nanoparticles can be lipids in a liposome. It can be composed of proteins, which is a protein drug conjugate frequently used in the medical field. It can be made up of polymers, of hydrogels, metals, or a carbon nanotube, such as what we talked about earlier. It can also take on a variety of shapes, such as spherical, cubical, or rod-formed. And due to its high surface area to volume ratio, nanoparticles can take on different charges. This will become particularly important whenever we discuss some of the medical implications. Here are some of the common sources of nanoparticles. The first is combustion of fossil fuels and renewable fuel sources. Then we can look at geologic minerals that are less than 100 nanometers found in the soil and in our ecosystem, aerosols that are dissolved into the atmosphere, and organic polymers and elemental metals that are synthetically formed. The diagram to the right shows you a few different ways that natural nanoparticles are formed in nature. One of the most interesting ones is cosmic dust, where small particles from comets that previously struck Earth have left nanoparticles in our area. Volcanic activity, weathering and wind erosion of rock, and as well as biomass combustion from natural vegetation. So, with the application of nanoparticles, it's amazing because there is such a wide variety and it really seems to target all industries that we know today. So, for instance, in the healthcare setting, nanoparticles have been used to great success in the delivery of cancer treatments, specifically for brain cancer, due to the nanoparticles being able to cross the blood-brain barrier. And in textiles, nanotechnology is used for UV protection and stain resistant in clothing fabrics. Silver nanoparticles are often weaved into socks, underwear, and sports clothing to reduce odors. Cosmetically, titanium oxide is used in sunblock cosmetics to block UV rays. Engineers have also been able to use nanomaterials to develop solar panels with tailored solar absorption rates. So this means that these products are able to absorb solar energy at a much higher rate compared to traditional solar panels. These traditional solar panels were mainly composed of thin sheets of metal which reacted with the striking light from the sun. So now that we're able to use nanoparticles, we can then get a much higher rate and a much higher amount of energy harvested from the same amount of sun. And in our environment, nanoparticles are often used to reduce levels of trace materials in groundwater and river systems. In addition to their use in textiles, silver particles have also been proven to be an effective antimicrobial. So this is a little bit about the environmental use of nanoparticles. There have been many studies done and many experiments done which look at how nanoparticles can be used to help remove contaminants from soil, from groundwater, and from our air. Specifically, nanoscale iron particles have been used for the detoxification of a wide variety of contaminants, such as chlorinated organic solvents, organochlorine pesticides, and PCBs, all frequently found in some of our water supplies. And in the oil fields of Canada, researchers at the University of Alberta are interestingly using nanoparticles to better filter some groundwater that is used in oil drilling. The water that is used in these fields becomes easily contaminated with salts, silica, calcium, magnesium, and other organic material. So current attempts to recycle this water are typically limited to ceramic filters. Now these can become problematic because oftentimes they're ineffective and are really only able to remove the salts and magnesium, sometimes the calcium, but for the most part they will end up leaving the silica particles and the organic matter. These filters can also clog up really easily. And so a nanomaterial membrane has been developed, and it's a much more affordable option, and it's also an effective solution that is able to capture a majority of the contaminants. But of course, it's worth noting that some of the advantageous properties that can come with their size in nanoparticles can also have harmful effects on soil and water when released into the environment and into our day-to-day lives. So, for example, some inhalation research has been done and it has shown that soot nanoparticles can have adverse health effects. Ambient air pollution may lead to cardiovascular and pulmonary disease. Some nanoparticles can also get into the body through the skin and the lungs and through the digestive system. And while inside the body, these particles are able to react with your cells and create what is called free radicals. These free radicals are able to run rampant and cause a great deal of damage to your tissue. And this is where it's always important to make sure that you're consuming a quality diet, because whenever you consume vitamins A, C, and E, which are antioxidants, these can typically reduce your levels of free radicals and improve your health. And the ingestion of some nanoparticles may also cause liver damage. So these nanoparticles can accumulate in the liver and may cause an exacerbated immune or inflammatory response. And so after looking at all this, we really need to realize that at the end of the day, there's not conclusive evidence, or better yet to say, there is not enough evidence that proves that nanoparticles are a significant risk to human health. A majority of the research done has been on animal subjects, and today we're really not sure whether the findings are relevant to humans. The nanotechnology industry is booming, and really research being done to study the health effects are often lagging behind. So it's really important that as we continue to grow the nanoparticle industry, we also continue to follow with it in a linear fashion research done to study how it affects us. These are some of the risk factors for exposure. These are ways that you could be exposed to nanoparticles. So one of the most common ways is through medical treatments. Polymer cages are often used to encapsulate medicine in nanoparticles, and because of their size, they can very precisely find disease cells in your body. Air pollution from power plants and combustion reactions from automobile engines are another major source of aerosols in the atmosphere. If you live in an area that's highly congested, or has a large industrial complex such as Los Angeles, Beijing, China, or New York City, this could be a high risk for you. Similarly, lifestyle choices such as consumption of well water or consuming tobacco products also puts you at a higher risk for exposure. Certain occupations such as mining, working at a power plant, and being around incinerators at your job can put you at a higher risk as well. Now, this is the shortest slide today, but I think it is one of the most important slides in the whole presentation. So the NTRC is a federal organization that coordinates and oversees research in nanotechnology, and they also help ensure that nanomaterials are handled well in the workplace. So in 2007, they released an article titled Progress Towards Safe Nanotechnology in the Workplace. This article covered topics such as risk assessment, epidemiology and surveillance, and guidance for employers on how to properly handle nanotechnology. While there are no federal regulations that mandate manufacturers to list whether, say, a product contains nanoparticles, I think that it's really important that moving forward, we really try to focus our attention towards nanotechnology and actually put in place laws and regulations that enforce specific practices to allow us to have safe work environments and to also ensure that our ecosystem does not suffer. These are some of the takeaway points from my presentation today. So number one, nanoparticles are commonly found throughout nature and in our lives. They're not something to be afraid of, but really something that we can embrace, and if watched carefully, can be incredibly useful. They can be either naturally occurring or synthetic. So in the topic of environmental health, nanoparticles can be particularly useful for removing contaminants from oil spills and improving air quality in highly congested areas. If you feel that you are at risk for nanoparticle exposure due to your lifestyle or occupation, I highly recommend that you pay attention to some of the negative health effects that we discussed earlier, and really don't hesitate to do any further research on nanotechnology if you feel necessary. Even though it's a relatively new industry, I believe that nanotechnology has the potential to improve our society and environmental health. Here are some of my references, and I would like to open the floor for any questions. Here is my contact information, so please reach out if you have any further questions or concerns about the topics that we talked about today. Thank you again for listening, and I hope you have a great day.